All right, here's a couple of examples of how to do some limiting reactant problems. So example 1 says 637.2 grams of NH3 reacts with 1142 grams CO2, producing urea and water. How much urea will be produced in this reaction? Now, of course, I wouldn't expect you to know the chemical formula of urea and any of these chemical formulas. I give them to you. So first of all, we write a balanced equation. Notice that there are two N's here, so we needed the two NH3s there. And then that is all you need to balance that equation. So first of all, we know this is a limiting reactant problem because they give us the amount of one reactant and they give us the amount of the other reactant. So the question comes up, well, which one do I use to figure out how much urea is going to get made? Is you have to use the limiting reactant. So the first thing we have to do is we have to figure out which one of those two is going to run out first. Is it the NH3 or is it the CO2? And how do you figure that out? You take one of the reactants, either this one or this one, it doesn't matter, and you convert to the other reactant. So you take the 637.2 grams of NH3 and you convert it to CO2. Or you take the 1142 grams of CO2 and you convert it to NH3. Either one will tell you what the limiting reactant is. I just chose to start with 637.2, but I'll show you what doing it the other way would also do. So 637.2 grams of ammonia. I convert my grams of ammonia to moles using the molar mass of NH3. And then I use the balanced equation to convert moles of NH3 to moles of CO2. 2 moles of NH3 react with 1 mole of CO2. And then I convert moles of CO2 to grams using the molar mass of CO2. And I get 824.6 grams of CO2. Okay, now, I just as easily could have started with my 11. Now, you don't have to do both of these. I just want to show you one time. I could have done it the other way. I could have gone 44 grams in 1 mole of CO2. And then I could have said 1 mole of CO2 reacts with 2 moles of NH3, and then 1 mole of NH3 has a mass of 17 grams. And then my answer would be 1142 divided by 44 times 2 times 17 equals about 882 grams of NH3. Now, using either of those two answers, you don't need both of them, but using either of those two answers, we can determine what the limiting reactant is. Okay, because again, that what this number here tells us, remember the answer you get, whether it's this one or this one, is this is how much you need. So when you have this much NH3, you need 824.6 grams of CO2. Okay, you have 1142 grams of CO2. You got plenty of CO2. You have, remember that the number in the problem is how much you have. The number that you get when you do the math is how much you need. So I need 824.6 grams of CO2. I have 1142. I have plenty of CO2. It's not going to run out, so NH3 is the limiting reactant. Okay, or the other way to look at it is I have 1142 grams of CO2, and to react with all of that, I would need 882 grams of NH3. I don't have 882 grams of NH3. I only have 637.2, which means I don't have enough NH3. See how in both cases, both of them tell me either I'm going to have more CO2 than I need, or I don't have enough NH3. Both of them tell me that NH3 is the limiting reactant. Okay, and this paragraph here kind of summarizes what I just said. Now that we know that NH3 is the limiting reactant, notice you'll never see me use this number. Remember, this is how much NH3 I need. This is how much NH3 I actually have right here. That's the amount I'm going to use to now answer the question. So I've got 637.2 grams of NH3, and now I just do the problem. 17 grams, 1 mole of NH3. 2 moles of NH3 makes 1 mole of urea. 1 mole of urea has a molar mass of 60, and I get my final answer of 1,124 grams of urea. Okay, one more example. 0.740 grams of ozone, O3, reacts with 0.670 grams of nitrogen monoxide to form molecular oxygen, which is this, and nitrogen dioxide. Okay, how many grams of nitrogen dioxide will be produced? So again, what's the first thing I have to do here? I have to recognize, ooh, this is a limiting reactant problem because they're giving me the mass of both reactants. So what am I going to do? I'm going to take my 0.740 grams of O3. I'm going to convert that to moles. 48 grams in 1 mole of O3. And then from my balanced equation, 1 mole of O3 reacts with 1 mole of NO. And remember, I could have started with this one as well, just like in that previous problem. And then 1 mole of NO has a molar mass of 30 grams. So now I go to my calculator, 0.740 divided by 48 times 30 equals 0.463 grams of NO. So again, whoa, not sure what happened there. So again, this is how much NO I need. So I need 0.463 grams of NO. I have, here it is up here, 0.670 grams of NO. So I only need 0.463, but I have 0.670. That means I have plenty of nitrogen monoxide, which means I'm not going to run out of it. So that means that is the excess reactant, which therefore means O3 is the limiting reactant. So now to answer the question, how many grams of nitrogen dioxide will be produced? I must use the amount of the limiting reactant that I have. So 0.740 grams of O3. There's 48 grams in 1 mole of O3. And then from the balanced equation, 1 mole of O3 makes 1 mole of NO2. And 1 mole of NO2 has a mass of 46 grams. Okay, and now again, I go to my calculator, 0.740 divided by 48 times 46 equals 0.709 grams of NO2. Okay, now, notice that the second question here, so that's our answer. How many grams of nitrogen dioxide will we produce? 0.709 grams of nitrogen dioxide. The second question says, what mass of the excess reactant is left over once the reaction is complete? To calculate this, you must calculate the mass of the excess reactant. So, first of all, we just figured out NO is the excess reactant, and we figured we need 0.463 grams of it. Okay? Well, how much nitrogen monoxide do we have? We have 0.670 grams of it. And we're only going to need, or we're only going to use 0.463 grams of it. Okay, so how much of that excess reactant is going to be left over once the reaction is complete? We're going to have to take the 0.670 grams of NO that we have, and we're going to subtract that 0.463 grams that we're going to need to react with all of that ozone. And that's going to tell us 0.670 minus 0.463 equals 0.207 grams of NO left over. So you've got to figure out how much of that excess reactant you need, like we did in this first step right here. Subtract that from the amount of the excess reactant you have. So this is the excess reactant, and it's how much we have, and we're subtracting the amount of the excess reactant that we need. Okay, and that tells us how much of that excess reactant will be left